Hello students, and welcome to section 1.1, points, lines, and planes. Today's I can statement is I can describe the undefined terms, point, line, and plane, and then we will also be answering questions and thinking more deeply about these three concepts. So point, line, and plane are actually what are considered to be undefined terms. And that means in mathematics, they have no formal definition. What's weird about that is you think back when geometry was being discovered or created, they really didn't have a way of defining what a point was, what a line was, what a plane was. So the mathematicians that got together, they said, okay, we are going to all agree that this is what a point is. We are going to all agree that this is what a line is. And we're all going to agree that this is what a plane is. And by the time they all agreed on that, even though they couldn't really define it in a super succinct way, they were able to all sort of agree and understand what those meant, and then they could go on and develop more geometry. So these are just informal definitions of what a point, line, and plane is. And again, I don't really think they make it any clearer what a point, line, or plane is, but you've seen these before, so hopefully this is not something brand new to you. You can go ahead and pause the video, but you do need to write these definitions down, and then we are going to talk about picture and notation for these three undefined terms. So first up is point, and point has no dimension. So a point is just a little dot in space. You've seen points before on coordinates, and it really just looks like a dot when we write it on a piece of paper. So it's like a dot. We name it with a capital letter, so I could call this point A. And notation for points is pretty simple. If you're referring to a point, you can either use the capital letter that you used to name it, so point A, or you can also say I have point A, and then you can give a location as an ordered pair. So an example, you could say A is at 2, -5, and then you could put that on a coordinate. A line has one dimension and extends without end, and basically what a line is it is a collection of points that go in a straight line forever and ever and ever. We've seen lines probably more than anything else in earlier classes. And the way that we typically name lines is we say, okay, let's find some points on the line. So this line has point B and point C. We can also give lines a little nickname. The nickname for lines is usually a lowercase cursive letter. So if you see a lowercase letter or a lowercase cursive letter next to the line that doesn't seem like it goes with one of the points, then you know that that's kind of the nickname for the line. So if we were describing this line, we could just call it line and then its nickname, so line L, and you do want to write it as lowercase cursive when you write it as well. Or you can use line notation, which is just a tiny little line with arrows on both ends. And then under that, you put the different points that are on the line. So you could say line BC, or since they go forever and ever in both directions, you can also swap them around and call it line CB, and it's referring to the same line. The last undefined term is plane. The definition, or informal definition, is it has two dimensions and extends without end. But I think plane is actually the hardest one for us to visualize because we've seen a lot of points and lines in the past. The way I imagine it is it's like a piece of paper that goes on forever and ever and ever. So it's just a surface, but it never stops. It's like if you had infinitely many lines next to each other and they just went on and on and on forever and ever, you would get a plane. So it's like an ongoing piece of paper. It never stops. Okay, if the earth was flat, that would be an example of a plane, if it was flat. The way that we define planes is very similar to lines. We look at the different points that are on a plane, because again, planes are made of infinitely many points, and we use those to help us with the name of the plane. So you can have D, E, and F, and then again, you could have like a little nickname with a cursive letter. And so I could say that this plane is plane DEF. And yeah, you can just write out those capital letters. So DEF It goes on forever, so you could also do them in different order. You could say E, F, D. That would be fine too. Or you can use the little nickname trick and you can just say or plain and then whatever the cursive letter was. So I did letter P. I get that these are abstract right now, but hopefully as we draw more pictures and do examples, you'll get a better understanding of points, lines, and planes. Now, once we have those undefined terms, we are actually able to formally define 3 other terms: collinear points, coplanar points, and intersection. So go ahead, pause the video, copy down those definitions, and then we'll talk about what they mean. So for collinear points, the definition is points on the same line. And we've actually seen this in an earlier example. Collinear points just are 2 points that share a line. So again, a line has infinitely many points, but a lot of times when we see a picture of a line or a figure, diagram, whatever you want to call it, you have 2 specific points on there. So we could call those A and B. I think on the answer key I posted it's E and F. Does not really matter. We can also give this line a nickname with a lowercase letter. We can call it M. And so notation-wise, there's not really anything new, but we can just say E and F are collinear on line M. And again, lowercase cursive because it's a nickname. So that's an example of 2 collinear points. You can have more than 2 collinear points. You could have the entire alphabet on the same line and they would all be collinear with each other. So you can kind of see how it gets wild. Coplanar points are the exact same concept, but instead of lying on the same line, they lie on the same plane. So if I had a plane, it'd be really cool if I had a plane. Just kidding. Geometry plane. Geometry. So here's a plane. Again, it goes on and on and on forever in all directions. I know I'm a fancy math teacher and I try to do it 3D style. I'm going to see what points are on here. So say I had point A, B, and C, and then say I wanted to nickname my plane H with a cursive E-H. All you would do for coplanar is you'd say, okay, well, here's my plane H. What points are on the plane? Oh, A and B. You could also say A and B and C. You know, any points that are on the same plane are coplanar. So A and B or A and B and C are coplanar. Where are they coplanar? They're on the plane, coplanar on plane H. There we go. So again, it's co just means like sharing. They're sharing a line, they're sharing a plane. The last thing that we're going to do for new terms is intersection. And it's really important. In the past, you've seen intersection, but we're going to define it a little differently. An intersection is the set of points figures have in common. So for example, most of the time we talk about lines intersecting because that is what you've seen the most of in the past. So you could have 2 lines, you could have line M, line N, and you could say, hey, these 2 lines intersect at a point, okay? Because when they're running into each other, there's a single spot in space where they're crossing and then they're never touching each other again. And the way you would say that using the notation is line M and line N intersect at point A. So if you need to finish copying some of this down, again, please pause the video and then meet me on the next page to go over some examples. All right, so we have a couple different examples, and these are just questions of can this happen? Can this happen? So we're practicing our vocabulary. Some of these are a little bit abstract and might be hard for you to think about. So if you don't really understand how you would do this on your own, see if you can understand my explanation and if you can just follow along. That's probably all we need for right now. So number 1, can two lines intersect? If so, how? Well, we actually just talked about this. This is something you've seen in other classes. You can have two lines intersect. How is just how they're intersecting. So what does it look like? And we just talked about that on the previous page. Yes, two lines can intersect. How do they intersect? They intersect at a point. For those of you who are thinking ahead, you could also say, hey, if I have two lines that are on top of each other, they intersect at infinitely many points, which is another way that two lines can intersect. But for today, an intersection at a single point is plenty to think about. Next up, can two lines not intersect? If so, how? Well, this goes back to some vocab you had in probably 7th or 8th grade. Two lines can not intersect. The way they do that is they run parallel to each other. So yes, this is possible. How? They are parallel. Question 3, can a line and a plane intersect? If so, how? So this one's a little bit harder to think of. So I'm going to suggest that you think of a line as like your pencil and a plane as a piece of paper sitting in front of you. So pause for a second and think, how could you get a pencil and your plane to intersect one another? And what would that intersection look like? Piece of paper, my stylus is going straight into the piece of paper. So I have a line intersecting my piece of paper. You see that? Say you have a plane that is laying down flat, like on a table, and then you have a line going through it, and it's actually going to just run into that plane at one spot. Do you see that? And that's what's going to be hardest for people to understand is like, well, how do a line and a plane intersect? Since they're running into each other at one point, we can say, yes, this is possible. They intersect at a point. Because again, an intersection is just what does the plane and the line have in common? Where are they in the same spot? And they're only running into each other right here. Okay, keep going. Can a line and a plane not intersect? If so, how? So again, let's go to the camera. This is a piece of paper, and here's a line. One way that you could have them not intersect is you can just hold the pencil or the stylus over the piece of paper. Do you see that? So that is one way where you can get the line and a plane to never intersect with each other. And it doesn't really matter which direction it's going. It's just like hovering. So imagine, if it was sitting on it, it would be intersecting, right? But it's not intersecting because it's levitating. So it's levitating off the piece of paper. So a plane and a line cannot intersect. The way that happens, because I haven't used orange yet, is you have a plane and then you have a line just hovering over it like this. So yes, it's possible. And you can actually say that those are parallel. Anytime you're not having an intersection, try to figure out if you can have something be parallel to the other thing. So next, can two planes intersect? If so, how? This is actually possible as well. I think it's a little harder to imagine, but imagine a piece of paper. And then imagine you have another piece of paper that's perpendicular to your first piece of paper. So this might be a little bit beyond what some people are imagining or able to imagine on day one. But it's like you have a piece of paper and then you have another one that's sticking straight out of it. And it actually goes through to the other side of the piece of paper. That is the way that two planes would typically intersect. So yes. Now, how is it possible? So here's what we want to think. What points are these two pieces of paper having in common? They're not just having a single point in common. They're actually having that entire line in common, because every single time you have a point on piece of paper A and piece of paper B, that is going to be the intersection. So yes, how do they intersect? They intersect as a line. Honestly, I think this is the hardest one to visualize. So if you're struggling with that, it's okay. Don't freak out. You'll be fine. And then number 6, can two planes not intersect? This is very similar to example number 4, except that was with a line in a plane. The way that two planes do not intersect is they have one hovering over the other. So again, they're parallel to one another. You have a plane, you have another plane, they're parallel, so they never intersect. So yes, that's possible. How is it possible? They are parallel. So those are those sort of thought-provoking problems. And now we can move on. So we have 2 examples. These are just looking at figures and answering questions about them. So example number 1, use plane R to answer questions A and B. So first, give 3 other names for line ST. And again, that is what this means. Line ST. So what I want to do is I want to look at this figure and I want to say, okay, where is line ST? Let's figure that out first. Line ST is the line that has points S and T on it. And if you notice, there's some other stuff going on line ST. We have a different point. Point P is collinear with points S and T. And all 3 of those points are collinear on line M. So that's kind of the nickname for this line. They're all the same line. So what we can do is we can use the nickname to define this. We can say, okay, well, this is line M. Again, do the squiggly little lowercase letter. We can also use different points. So instead of doing ST, since P is collinear, we can call this line SP. And it's the same line. You could call it line PT. Any of those points that are collinear would be fine. You could also go the other direction. So you could say line PS, line TP. B, name a point that is not coplanar with points V, S, and T. So if we get rid of these notes and we say, okay, name a point that's not coplanar with points V, S, and T. So coplanar is these points, V, S, and T are on a plane. We can see that. The plane is the plane on your picture. So we have plane V, S, T. We could also call that plane R. So that's going to be that red picture. So we need to find a point on the diagram that is not on the red plane. And you can see we kind of have this one that's just hovering above the piece of paper or above the plane. That is going to be our point that is not coplanar. So it's going to be point Q. You can just say Q, uppercase, or you can write out point Q if you want. We do care about uppercase and lowercase letters. It's very important. Notation is one of the most important things in geometry. Okay, now we're going to have a slightly more complicated diagram. So this is a diagram on the right. Use the diagram of the intersecting planes to answer the following questions. And again, I think the best way to explain this is just with some strategic highlighting. So name 2 planes in the image. Well, we have 2 planes going on here. We have this plane, which is plane B. We have this plane, which is plane A. Okay, I know that the name of the planes is in the corners. You could also define it by the points, but I say we do the short little nicknames because, you know, let's be lazy. So plane B, plane A. B, name 2 lines on the image. So there's 2 lines that I can see. I have this one, and I just need to figure out how to name them. So this, the little line in the middle is easy because it has the nickname on it. So line K. I'm going to go ahead and just write that out. Line K. I'm going to do that in cursive because it is a lowercase letter and it's a line, so it should be in cursive. And then I need to name this line as well. This line does not have a name on it, does not have a nickname, but it does have different points. So I can define it using the points. I can call it line PQ. Again, notation, a little line with arrows on both sides, capital letters PQ underneath. Okay, next, name the intersection of line PQ and plane B. So here is line PQ, here is plane B. So I want to think to myself, how are those intersecting? This is an example. It's like a piece of paper with a pencil that goes through it. You have a piece of paper with a pencil that goes through it. It's only going to intersect at one spot right here in the middle. And that spot is already named on our graph. It is point M. And that should be uppercase, so let me make that clear. I know I'm moving, but I don't want this video to last forever. So example D, name the intersection of line PQ and line K. So again, let's do some strategic highlighting. Here's line PQ, here's line K. When two lines intersect, they intersect at a point, and it's named on the graph, so that's also going to be point M. E, name the intersection of plane A and plane B. So strategic highlighting, here's plane A and all of this in the middle. Here's plane B and all the stuff in the middle. And this one's really hard to visualize, but if we go up to this example, example 5, can two planes intersect? If so, how? Yes, as a line. So try to imagine we have two planes intersecting. We know they're going to intersect at a line. What's the line going to be where they intersect? They actually intersect all of line K is going to be the intersection of those planes. Because when plane B and plane A intersect, they're both going to have all of line K on their planes. Again, that's another kind of tricky one. If that is just mind-blowing to you, don't freak out. It'll be all right. Lowercase, cursive, because it's a nickname of a line. Lastly, name the intersection of line K and plane A. So line K is here. Plane A is here. So think to yourself, what do line K and plane A have in common? Well, line K is actually on plane A. Do you see that? Line K just lays on plane A. It is going to be on plane A forever and ever and ever. So what total do those two have in common? Well, line K is going to be the entire intersection of those two things. So if line K is entirely on plane A and then plane A has all these different points, the points they have in common are just going to be every point that is on line K. So that is the first lesson. We're going to go do some extra help live in WebEx, and I will also upload this key. If you missed anything, you can go check that PDF.